So, algorithms. This point in section 3.11, which we spoke about last time, talks about using pseudocode, program code, and flowcharts. So these are the three different things we're going to talk about today, and how you can compare all three of them to look at an algorithm. So the standard example, which you've probably seen before if you're revising and is done to death, but it is a good example, is making tea. So pseudocode first. Pseudocode is code that doesn't really represent any actual programming language. No computer can take it and then read it and just like make things happen. It's more just a general notation that we use without any particular programming language, just to represent a series of steps to do things. So pseudocode might look something like this. This is not really the AQA standard because it's all about boiling kettles and stuff, so you can't really do the same thing. The AQA standard looks to me to be mostly for mathematical problems, which we'll look at later. But you might say something like boil the kettle. The tea bag now means a tea bag that you've got from the cupboard. Put the tea bag into the mug. Pour the water into the mug, and then output to the screen. Would you like to add sugar? And then the user will input whether they want to have sugar or not. If the sugar choice is yes, then add sugar. Otherwise, don't do anything because there's no that's sort of done. Technically, you should put I guess end if in some languages to show like if that's not happening, carry on. Then remove the tea bag and output the tea is made. You're done. So as I say, this shows you how to make a cup of tea in a sequence of steps. It's almost like a recipe. This is how an algorithm essentially runs, a sequence of steps to achieve a goal. But this is in pseudocode, not in any particular language. It's just general. Now, the next one on the list they give is program code. Now, in this course, you can be using one of these three languages. I'm assuming as a student you don't get a choice. Hopefully your teacher didn't choose Visual Basic. In general, C# is pretty good. Python's the easiest and probably the best to learn. And I'm going to be showing you Python now because I suspect it's what probably most people are learning. These are examples of actual programming languages which can run on computers to really do things. So program code. This is some Python that I made. It's kind of sort of pretend because the classes don't really do anything, but it sort of works. So if we have our algorithm, this is what it might look like in Python. We create a kettle, a cupboard, and a mug. These are kind of objects. You don't have to worry about objects work. I don't think they're even in your course, but we just create a kettle, a cupboard, and a mug. We're going to say boil the kettle. The tea bag now equals cupboard.getTeabag. That means get a tea bag from the cupboard. Then into the mug, we're going to add a tea bag, and we're going to give it that tea bag to use. Then into the mug, we're going to add water, and to get the water, we're going to pour it out of the kettle. Then we're going to ask the user, would you like to add sugar, and assign whatever they input into the system. Remember, inputs are the user putting data into the computer. They're going to ask them if they want sugar. If they say yes, that's what this line does. If they say yes, then sugar will equal get some sugar from the cupboard, and then add sugar. Then this is now done because it's this indentation is done, so that if statement's happened then. Then into the mug, we're going to remove the tea bag, and finally print tea is made. And so when we actually run this, you can see it happening. The kettle boils, it's now boiled. They put the tea bag into the mug, the tea is brewing. Would you like to add sugar? And it's going to ask me, and I have to literally say yes. And then it's added sugar to the tea, remove tea bag, the tea is made. So this is actual program code that actually does stuff. And as I said, if you're not doing Python, don't worry how this works. Even if you are doing Python, don't worry how this works because I don't think you even use classes in GCSE, but I'm not sure yet. Essentially, the point is this is a language that a computer can read and can do things with. This is really useful because it's useful for explaining stuff to people who don't understand the particular language. So if you're a Python programmer and you show this to your friend, but your friend doesn't know any Python, then they might not understand what you're on about. Whereas this is fairly standard and anybody can understand this, whether they're a Python programmer or a C programmer or a Java programmer or a Haskell programmer even. So this is a general way of representing some code without understanding that in Python, to create an if statement, you have to say if space thing equals thing and then a colon, or in Java, you put the thing in brackets. They're all different in different languages, but in pseudocode, it's just a general whatever works. Finally, we have the flowchart, which you've probably seen before. They're very straightforward. I nicked this off the internet, and they actually remembered to put milk in as well, which I forgot to do. With the flowchart you have, there's a convention based on the shapes, but I don't think you're expected to understand it. Essentially, this sort of capsule thing means a start or a finish. A square means do a thing, and then a diamond means a decision. And you see it says yes or no, so it says start, then get a cup, then boil the kettle, then ask, is the kettle boiled? If it's not, you boil it again. I don't really know how that works, but I suppose you keep reboiling it until it is boiled. If it is boiled, you see it says yes, that decision, put the water in the cup, add the sugar, add the tea bag, put the milk in, stir it, take tea bag out, drink it and enjoy. So that's how each of these three things work. In an exam question, I would expect you would be told to do something like, here is a flowchart for making tea, turn it into some pseudocode, or maybe write it in Python. Understanding the relationship between all these three things is fairly straightforward. What I would say is, remember, if you get stuck, go back to the definition of an algorithm. An algorithm is a sequence of steps. It is a sequence of steps that you do one by one, and all of these model that. The flowchart says a step, a step, a step, a step, a step. It's doing a sequence of steps. The pseudocode again is doing step by step by step by step. It's a sequence of steps, and of course the program code is also a sequence of steps. And typically you can map one to the other. So there is a add tbag step in Python. There is an add tbag step in the pseudocode, and there is an add tbag step somewhere here, an add tbag step in the flowchart. So obviously I just realized this flowchart does things in a different order because T is ambiguous for some reason. But the important thing is, remember that we're ultimately looking at a sequence of steps one by one, and each of these is a way of explaining that. And it says in exam questions, you'll be told what they want you to use. As I say, I suspect they typically give you a flowchart and ask you to write pseudocode, or give you some Python and ask you to write that into pseudocode, or something like that. Get familiar with all three standards. In a lot of coursework specs and a lot of test things, a good practice to use is whenever you have a problem, draw a quick flowchart, then write it in pseudocode, then write it in Python or C# or VB. It's a lot of work. It seems silly when you're writing pseudocode. In practice, let's be honest, you wouldn't actually write pseudocode for a program before you go on to write Python in it. That's not what anyone would really do, but it's a good tool to use. And if you work, especially if you work in a big team, I myself do this. I work in a big team full of people who don't know how to program very well, and so they can give me code in pseudocode because they don't know how Python works, and I can then turn that pseudocode into Python. That's why pseudocode is useful. It seems a bit silly, but it is really quite useful. Flowcharts, obviously, always useful. Program code, obviously, that's what we use as computer scientists.